here in the previous lecture we have seen or we have calculated the structural error, and you don't need any of these values. Don't worry about what is structural error and how it is calculated from convergence and other sorts of things. You just need simple fact that in whatever areas there is high structural error, you can just refine your mesh at that particular area. So for example, for this problem, what happens near this edge, we have more amount of structural error. So what I'm going to do is I'm going to go to the mesh. Now I'm going to put up some local conditions or local refinement controls in order to modify my mesh. So I'm going to right click, say insert, and I'm going to say sizing. So once I select the sizing, I'm going to select see here I'm only able to select the faces, but right now what I want is I want to select only edges. So for that I'm going to change my selection tool to edge selection, and I'm going to select this edges. See here, by pressing Ctrl I'm going to select multiple edges. See, I'm selecting this multiple edges. So what happens is, instead of refining the total body, if you refine it locally, what happens, the number of equations to be solved or the number of nodes or elements that are formed will be lower, and we can have a much efficient solving process or much efficient solving time. So once I am done with the selection, I am going to press apply here, and you see the default element edge size is 14.523 mm, which may be good, holding good to this type of edges, but these are very small edges, so we need to say we'll reduce it to 2 mm or so. And once we have done this, we are going to regenerate the mesh. We are going to regenerate the mesh by right clicking on that, and we can just say generate mesh. Now you see, in comparison with the previous mesh, what happened, the refinement has occurred at this particular edges. And if you can even now go to the information, and you can see that from the statistics you can see the number of nodes as well as elements may have increased. So once I have done this, I need to recalculate all these particular values. So what I need to do is I need to solve the problem once again, because I have changed the total mesh. So changing the total mesh means you are going to change the total skeleton of the problem. So you need to again rerun the calculations, and once you rerun the calculation, now you come to the structural error. See here, so most of the structural error has gone. So this is how you can use the structural error option to refine the mesh in the areas of critical say requirement, and then you are going to have a good mesh without much increase in the computational time or effort. So in the next lecture we are going to see how to analyze an assembly. Until now we have we have analyzed 3D objects, single components, but in the next lecture we are going to go and we are going to analyze a 3D structural problem, assembly problem, where we are going to define contacts, and we are going to see how to change the behavior of the contacts, and we are going to apply these same loads, structural loads, and we are going to see whether this is going to withstand the loads or not. Thank you.